Here we have two vectors, u and v is obtained from u by multiplying u by 1.5. So it's a result of a scalar multiplication. Now let's try to figure out if we have the coordinates of u and they are equal to, in this case, -2 and 1. Let's try to figure out what are the coordinates of v, how to obtain the coordinates of v having the coordinates of u and the scalar factor. Here in this case it is 1.5. Now you can notice that we have here two similar triangles. QOQX is similar to POPX, and they are similar because the vectors OP and OQ, they point at the same direction, so the angles at the vertex O are the same, and both triangles are right triangles, so the respective angles of both triangles are equal. Now, because the length of vector v is 1.5 times bigger than vector u, so OQX is 1.5. The distance of QX from O is 1.5 bigger than the distance of PX from O. And both here, QX and PX, the coordinates are negative because they are left to the origin. And this explains why the coordinates px and qx, qx equals to 1.5 times the coordinate of px. And the same, using the same method, we can show that the y coordinate of q is 1.5 times the y coordinate of p. And this explains why when we want to find the coordinates of a scalar multiplication of vector v, we multiply vector u, we multiply both coordinates of vector u by this number. Here in this case it's 1.5, so vector v has coordinates -3, which is 1.5 times -2, and its second coordinate is 1.5, which is 1.5 times 1. Now if I, for example, change this vector to, let's make it here, nicer numbers. So here is a vector of coordinates -3 and 2, and I multiply it by 1.5. The coordinates of the vector that I receive after multiplying q by 1.5 are 1.5 times -3, which is -4.5, here -4.5, and the second coordinate is 1.5 times 2, which is 3, and here it is 3. Now let's move the point here, and let's see what happens if we multiply the vector by a negative number, a negative number, here by -1. And once again we can see that we have two similar triangles. OQQX is similar to PPXO, and because the angles here at O, at the vertex O, are the same, they are equal, and they are both right angle triangles. And you can see that here the x-coordinate of Q is positive, and which we obtain by multiplying the first coordinate of P of vector u by a negative number, by -1. And y coordinate, the second coordinate of Q, is negative, which again we obtain by multiplying the second coordinate by -1. -1 times 1 is -1. So if we want to get a coordinate of a scalar multiplication of a vector, we multiply the coordinates of the vector, each coordinate of the vector by the number that we multiply the vector by. So here, for example, by 2, 2 times -2 is -4, and 2 times 1 is 2.